Good morning, children. So last class discussed up to 1 ampere. So இதே ampere நம்ம 11th படிச்சிருக்கோம். So after that ampere, so here our new topic is torque on a current loop. So ஒரு current loopல எவ்வளோ torque produce ஆன்றதை நம்ம இதில் பார்க்க போகிறோம். So we having a derivation. So using the derivation, we can calculate how much torque will be produced. So what is the main thing in this torque on a current loop is the force on a current carrying wire. ஒரு கரண்ட் ஃப்ளோ ஆகிட்டு இருக்க ஒயரில் ஃபோர்ஸ் கிரியேட் ஆகுது when the current carrying wire is placed in a magnetic field, and this principle is responsible for motor operation. நம்ம எலக்ட்ரிக் மோட்டார் வீட்டில் யூஸ் பண்ணுறோம்ல டு பம்ப் வாட்டர். ஸோ in that process we are using this concept. So current carrying wire, so current இதுக்கு தேவைப்படுது, it is placed in a magnetic field, then some force will be created there, okay, and that force is operating the motor. It is used to pump the water easily from ground to first, second or third floor, etc. This is the main concept in this we are using. So எப்படி அந்த கான்செப்ட் இதில் யூஸ் ஆகுது, how the magnetic field and electric current playing in this, we'll discuss here. So we are clear about whenever the electric current is flowing through the conductor, around that conductor some magnetic field will be produces there. இது நமக்கு நல்லாவே தெரியும். So that concept here we are discussing with the help of magnetic field. So we having a topic 3.11.1, torque on a current loop placed in a magnetic field. Say we having the rectangular loop PQRS carrying a current of I. It is placed in a uniform magnetic field. So PQRS is like rectangular loop we are having, and it carrying a current with the value of I. It is placed in a magnetic field. Okay, uniform magnetic field. The unit vector is normal to the plane. The unit vector is normal to the plane, and the diagram is given here. And this rectangular coil perpendicular is acting theta with the magnetic field. See here in this figure 3.57, this red color is denoting the north pole, and this blue color is south pole. And we know the magnetic lines of force always starts from north pole and towards the south pole. It is shown in this figure. அதுக்கு முடியல we having the rectangle loop PQRS. இதோட நார்மல் பார்த்தோன்னா இந்த PQRS நார்மல் தீட்டா ஆங்கிளில் மேக்னெட்டிக் ஃபீல்டுக்கு ஆக்ட் ஆகிட்டு இருக்கு. So then based on this we are going to start our derivation, and here we are going to find out the magnitude of the magnetic force acting on each arm. So say here we having the rectangular loop, namely PQR and S, and PQRS is taken as the side A, and QR and PS is taken the side of B breadth. Okay, and now the force along the PQ arm, இதுதான் PQ arm. இந்த PQ armல force என்னன்றதை நம்ம calculate பண்ண போகிறோம். The current is flowing in the direction of PQRS. So already we having the formula for force. F is equal to BIL sin theta. What is the formula? F is equal to BIL sin theta. இது நம்ம ஆல்ரெடி டெரைவ் பண்ணியிருக்கோம், லாரன்ஸ் ஃபோர்ஸில் டிஸ்கஸ் பண்ணும்போது அதிலே பார்த்துருக்கோம். We are going to use the formula for this arm PQ. Then force on the PQ we can write as FPQ is equal to I A B sin pi by 2. So I B I L நம்ம அங்கே யூஸ் பண்ணோம்ல, சேம் ஃபார்முலா. B same magnetic field, I is current on the loop, then A. Here அங்கே நம்ம L length யூஸ் பண்ணோம். So in that place here we are substituting A. Then sin theta என்ற placeல we are using here the angle between PQ arm versus magnetic field is pi by 2. Then sin pi by 2 will become as 1. Then we are writing the formula BAI. Okay, we got the answer IAB. And this direction of the force we can explain with the help of right hand corkscrew rule. What is right hand corkscrew rule? We have to hold our right hand. 4 fingers are parallel to each other. Thumb will be raised there. Thumb will shows the direction of electric current, and the 4 fingers will shows the direction of magnetic field. Okay, we understood, no? So using that, we are explaining here the force. It is acting here in upward direction. Okay, it is acting here upward direction. So we are using here right hand corkscrew rule to show the direction of force. Then the magnitude of the force of the arm we are calculating for arm QR. So for QR we can write, we are using the same formula, FQR is equal to, here in basic formula L will be replaced by the term B. We are using small b by replacing the term of L from the basic equation. So what is the basic equation? BIL sin theta. Here we are writing IBB sin pi by 2 minus theta. So this pi by 2 we are taken this arm QR with the magnetic field. So QR arm magnetic field direction ko என்ன angle இருக்கிறதா இதில் நம்ம எடுத்துக்கிறோம். So that we can write as pi by 2 minus theta. So sin pi by 2 minus theta we can write as cos theta. Then the equation will become IBB cos theta, and its direction is shown as like a figure. We are using the corkscrew. And next we are giving the magnitude of the force on the arm RS. That is FRS equal to, we can write as IAB sin pi by 2. And here sin pi by 2 is taken as 1. Then the equation will become IAB in the direction of it is acting downwards. Again we are using corkscrew rule to explain the force. And the magnitude acting on the arm SP. So that is top of the rectangular. Then FSP is equal to IBB sin. Here the angle of the arm SP is added with the angle with the magnetic field, that is pi by 2 plus theta. Then formula will become IBB cos theta. Its direction is shown in the figure. So since the force FQR and FSP are equal but opposite and collinear, okay, so same line of action at the same time opposite direction, then we can say these two are cancelled to each other. But the forces FPQ and FRS, which are equal in magnitude and opposite in direction, it is not a straight line, it constitutes a couple. So it constitutes what? Couple. About couple we discussed in 10th itself. Okay, we can use that formula. So that is given clearly in this picture from PQ and RS in the figure 3.58. See, these two lines are acting in opposite direction. Its line of action is not coinciding. It constitutes what? It constitutes a couple. And now we are going to find out the formula for couple. Torque about PQ, arm PQ. Then torque tau PQ is equal to, we can write B by 2 sin theta. So what is B by 2? It is the distance, perpendicular distance. So couple torque is equal to, we can write B by 2 sin theta IAB, and it is points direction of AB. So AB is nothing but axis. Okay, so in this loop PQRS is fixed with the axis of AB. So it is acting along AB. And the magnitude of torque along the couple arm RS about AB, we can write tau RS is equal to. So we know how to calculate the torque perpendicular distance into any one of the force. Then we are using perpendicular distance is B by 2 sin theta IAB. So B by 2 sin theta எப்படி calculate பண்ணுறது நம்ம basically நிறைய answersல derive பண்ணியிருக்கோம். So hope you all know about this formula. Same direction AB, and the total torque we can write, we can add these two arms torques. Tau is equal to B by 2 sin theta FPQ plus B by 2 sin theta FRS. And the equation will become IA B sin theta of B. IA B sin theta of B. That we can write with the formula tau is equal to, and see here, this A is length and B is breadth. Length into breadth in this rectangle will be taken as area. then we can write IAB sine theta is acting along the AB. So in vector notation, we can write IA vector cross B vector. So how we can write IA vector cross B vector? This is the formula for torque, and this above equation also can be written as in terms of magnetic dipole moment, tau vector is equal to PM vector cross B vector. So already in the PM vector oda magnetic dipole oda formula நம்ம எழுதியிருக்கோம். That is nothing but IA vector. இதை நம்ம ப்ரூஃபும் பண்ணியிருக்கோம் இந்த யூனிட்டோட ஸ்டார்டிங்கில். Okay, IA vector, and the tendency of torque is to rotate the loop as to align the normal vector with the direction of magnetic field. And this is for single turn. If it is single turn, we can use this formula. Suppose we having n number of turns means the equation can be written as, so here this formula is for single turn. அதே நம்ம n number of turns அந்த rectangular coil இருந்துச்சுன்னா, that equation will become tau, the total torque is tau is equal to NIA B sin theta. Okay, what is the formula? NIA B sin theta. This is the total torque produced by this rectangular loop. Okay, so have you understood, children? That doubt இருந்தா you can ask me through WhatsApp or a personal call. And there are two special cases. So first special case, suppose the angle of the loop is 90 degree, means theta will be taken as 90 degree. The plane of the loop is parallel to the magnetic field. Then the torque and the current loop is maximum when we are substituting theta is equal to 90 degree. So IAB sin 90 is equal to, will become sin 90 is 1. Then the torque will become IAB. Suppose in special case 2, the theta of the rectangular coil may be 0 or 180, means sin 180 or 0 will become 0. Then the answer of torque will become, in this current loop, will become 0. We can say the torque produced by this is minimum value of 0. Okay, these two special cases we are understanding from this concept. Okay, so in the concept இல்ல ஒரு simple method. என்ன method அப்படின்னா, whenever the electric current flowing through the conductor placed in a magnetic field, it experiences a force. So this force is active in PQ and another one arm which is called as RS. These two arms contributing the force here, and this force are responsible to produce the torque. Okay, and it gives the answer here. So it is very clear. And what about the QR and the SP force? It also contributing the force, but it is acting in the same line. Then it is cancelling. So it is not responsible for here torque because it cancel to each other. And force இருக்கு equal but in opposite. So it cancel to each other. So based on the torque, here we are explaining for this rectangle. So it is very clear. It is explained with the help of two special cases when theta is 90 degree and theta is equal to 0 or 180 degree. So we got the final result. What we will get for force or torque? This rectangle loop is placed in a uniform magnetic field. Okay, are you clear, children? It is an important question. Okay, and after that we are moving to next topic. Moving coil galvanometer is also important. So the galvanometer, the device which is used to detect the current in an electric circuit. So what is the use of the galvanometer? It is used to detect the flow of current in an electric circuit. And here the principle is like a same last topic. The principle is, when a current carrying loop is placed in a uniform magnetic field, that loop is experiencing a what? Torque. It experiencing a torque. This is the principle used in this moving coil galvanometer. Okay, and this moving coil galvanometer is shown in this figure. We having the rectangular loop that is made by metal. It is in the shape of rectangle. So rectangular metal loop is there. So over the loop we having more number of turns of copper. Okay, copper wire is turned on this rectangular loop. More number of turns are there. And this rectangle loop, the top coil is connected with the phosphor bronze stripe, and bottom of this rectangular coil Wire is connected with the same passable bronze, but it is like a hairspring. So if small force, small twist happens, it started to deflect. Okay, and this rectangular loop arrangement is placed in between the horseshoe magnet, like a U-shaped magnet. You can see in this figure 3.5b 59 second one. It is placed in between the horseshoe. So whenever the electric current is flowing through that, it gets a reflection because of the sensitive wire which is connected at the bottom of the coil. And there is a mirror in middle. This mirror will show the reflection, and it will give the error. It will give to avoid the error of parallax method. இதை பற்றி நம்ம 11th first unitல படிச்சிருக்கோம். Okay, then we can take the perfect reading. This is construction, and here we can explain the working the same. If you understand the last topic நம்ம படிச்சோம் ரெக்டாங்குலர் கையில் எப்படி ஃபோர்ஸ் ப்ரொடியூஸ் ஆகுதுன்றதை நீங்கள் அண்டர்ஸ்டாண்ட் பண்ணிட்டாலே இந்த ஆன்சர் இஸ் நத்திங். அதை வச்சு தான் நீங்கள் இதை அண்டர்ஸ்டாண்ட் பண்ண முடியும். ஸோ யூ ஷுட் தரோ த டாபிக். ஸோ சேம் we having the rectangular coil PQRS. Here PQ and RS is taken as the length L. அங்கே ஏன்னு எடுத்துக்கிட்டோம். Here we are taken as L. And QR and SP is taken as B. Say I current is flowing through the rectangular coil PQRS as shown in the figure 3.60. And horseshoe magnet hemispherical, we discussed about that. And here this magnet, this horseshoe magnet is giving the radial type of magnetic field. It is always perpendicular to the magnetic field and experience equal force, and opposite it constitute a dipole. Then we are coming to the point. So at beginning we discussed in the rectangle loopல வந்து நிறைய number of turns of the copper coil இருக்க மாதிரி தான் நம்ம intro கொடுத்தோம். But for calculation purpose we are considering only one turn of the coil அப்படின்ற மாதிரி நம்ம எடுத்துக்கிட்டோம்னா, then the equation will become here the torque is tau is equal to B into F. So what is B? B is the distance. Okay, perpendicular distance between the two force. இதுவும் நம்ம 10thலயும் படிச்சிருக்கோம், 11th சில டாபிக்ஸ்ல படிச்சிருக்கோம். So I hope you are well versed in this. Then force, we know what formula we can substitute. BIL, இதுவும் நம்ம previously discuss பண்ணிருக்கோம். So B into BIL, and here small b and small l are separated. So LB will be taken as length into breadth of the rectangular will become what? Area of the rectangular. Then the equation of torque will become ABI. Okay, this is for single turn. Suppose we are having n number of turns, means the same formula can be written as NABI. So what formula we can write here? NABI, this is a torque produced by this rectangular loop. Okay, and due to this deflecting torque, the coil get twisted, and some torque that is called as restoring torque which is developed here. If torque is developed here, that means that is nothing but a restoring torque. That torque is proportional to amount of twist. Then we can write the formula. In the formula directly use பண்றோம். Okay, இப்போ இதை just தரவு பண்ணிக்கோ. In future we'll study about this explanation. Higher studies இதை படிப்பீங்க. Then torque is equal to K theta. K is constant here, and K is nothing but a restoring constant per unit twist. So at an equilibrium, the deflecting couple must be equal to the restoring couple. And then we can write the formula NABI is equal to K theta. So அங்கே ஒரு torque produce ஆகுது, this restoring couple producing torque, both are same. Then we can equating the equation NABI is equal to K theta. Then I is equal to, we are sending NAB to right hand side, then it will become K by NAB theta. Then K by NAB will be as G. It is called as galvanometer constant or current reduction factor of the galvanometer. Okay, and here the suspended moving galvanometer is very sensitive, so we have to handle this galvanometer with a very careful manner. If the extra current is flowing through, that means it may damage the galvanometer. So we have to look at that when we are connecting with the circuit. Okay, so about moving coil galvanometer, it's over. This answer is based on last derivation. So last derivation full thorough பண்ணிட்டீங்கன்னா this answer will be more easy for you. Okay, so hope you all understood about this moving coil galvanometer. and we'll mark question answer here. Okay, so last one important question about the torque and a current loop placed in a magnet. You can start from here. Okay, consider ஆரம்பிச்சு so you can write the question, explain about torque and a current loop placed in a magnetic field, and you can extend this answer with these two diagrams up to next page, the two special cases just about the moving coil galvanometer நீங்க முடிச்சுக்கலாம். Next 5 mark question, and this is also important detailed question, and this answer you can start from the starting of this topic, explain the construction working of moving coil galvanometer inga ஆரம்பிச்சு these two diagrams, then you can extend up to here, moving coil galvanometer. Okay, you can have extend up to here, moving coil galvanometer, and these two figures are given. So this is answer for moving coil galvanometer. And children, for today's test, you can take the topic torque on a current loop placed in a magnetic field. Okay, torque on a current loop placed in a magnetic field. 3.11.1 மட்டும் இன்னைக்கு டாப்பிக்காக எடுத்துக்கோங்க. எடுத்துட்டு நல்லா தரவு பண்ணிவிட்டு you write in your homework part, then you send that image to me as a homework. Okay, thank you children. The rest of the topics we discuss in upcoming classes. Thank you.